All right, guys, we are going to be talking about section 11.4, fundamentals of probability. All right, so we have computing theoretical probability and empirical probability. All right, with probability, it's going to be between 0 and 1. It cannot be greater than 1. It cannot be less than 0. If the probability is 1, it's absolutely positively going to happen. The sun is going to rise in the east, 100% probability. On the other hand, something that's impossible, then the probability would be 0. The sun rises in the west. That's impossible. So that would have a probability of 0. And then stuff in between is more or less likely depending on what you have. All right, some definitions. An experiment is any occurrence for which the outcome is uncertain. This is just math terminology, so don't worry about it too much. Sample space, the set of all possible outcomes. We use S to indicate sample space. I didn't mean to do that. Event is any subset of the sample space, and the sum of all probabilities, theoretical probabilities, has to equal 1. Okay, I'm going to say that one more time because that's important. The sum of all the theoretical probabilities has to equal 1. All right. If an event has equally likely outcomes, then the probability, theoretical probability, is the number of outcomes in the event divided by the total number of possible outcomes. That's going to make more sense when we do some examples. But basically what we are looking for is the number of ways we can get what we want divided by the total possibilities. What we want divided by the total. What we want divided by the total. All right, so for example, we have a die, it's rolled once. Find the probability of rolling a 3. Well, they're talking about a 6-sided die. They're not talking about any of those unusual dice. They're just talking about a 6-sided die. And there's only one 3 on a 6-sided die. So there's only one way to get what we want, which is a 3 out of 6 total possible outcomes. It could be a 1, a 2, a 3, a 4, a 5, a 6. So altogether, there are 6 total possible outcomes, and there's only one way to get what we want. On the other hand, the probability of finding an even number, well, the even numbers are 2, 4, and 6. So those are the outcomes that are possible, that are even. Those are what we want. So there's altogether this 1, 2, 3 ways to get what we want. Again, out of 6 total, you would simplify this to 1/2. So the probability of getting an even number would be 1/2. Yes. You were dealt one card from a standard 52 card deck. A little bit of background about a 52 card deck. There are 4 suits, what we call a suit. There is red cards and black cards. Half the cards are red, half the cards are black. The red suits are hearts and diamonds. So there are half of the half, meaning 13. There's 13 hearts, 13 diamonds. And then the black cards are spades and clubs. So half of the black cards are spades. There's 13 of them. Half of the black cards are clubs. There's 13 of those. So there's 13 in each suit. In each suit, they have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then they have a jack, a queen, and a king. So those are the different cards. If they ask about a face card, those would be the jacks, the queens, and the kings because they have faces on them. They're called face cards. So find the probability of being dealt a king. Well, there are four kings, one of each suit. So there is a king of spades, king of clubs, king of hearts, and king of diamonds out of 52. You simplify that and you get 113. So if you are randomly dealt a card in, they say a well shuffled deck. So no cheating involved. They're just completely shuffled. The probability that you would draw out a king is 1 out of 13. We talked about hearts. There are 13 hearts in a 52 card deck, and we simplify that, and that would be 1/4. So probability of getting a heart is 1/4. On the other hand, empirical probability has to do with what actually occurs as opposed to what should occur. So the number of times it's observed as opposed to the theoretical probability. For example, if I toss a coin, the theoretical probability, let's say I toss a coin 10 times. The theoretical probability is that half of it is going to be heads and the other half is going to be tails. So probability of getting heads would be 1/2. On the other hand, if I do empirical probability and I actually do toss the coin, and suppose I get 9 heads out of the 10 coin tosses, then the empirical probability would be 9 out of 10, as opposed to the theoretical probability, which is 1/2. So empirical is what actually happens, what's actually observed. All right. One person is randomly selected from the population. Find the probability that the person is female. So what you're going to do is you're going to look and see how many female people there are that was surveyed out of the total population. So the probability that you would be talking to a female would be 124 females out of a total population of 242. You would simplify that. I don't have a calculator handy, so I'm going to go to the next slide where it is calculated for me. It's approximately 0.51 or 51%. All right. All right, and that is the end.